In this video, we're going to look at CC3, which is on atomic structure. This is a topic that comes up on paper 1 and paper 2. In this video, we're just going to look at the first part of this topic, which is atomic structure. So Dalton was a scientist and he published his theory on atoms. I've outlined that theory in the bullet points below. You'll see that there are 2 points that are underlined. These are the points of his theory that were later proved to be untrue. So if I look at the second point here, atoms cannot be broken down into smaller parts. That was later proved to be untrue. We now know that atoms can be broken down. They can be broken down into protons, electrons, and neutrons. He also believed that atoms were tiny hard spheres. We now know that that's untrue. Protons and neutrons exist in the nucleus at the center of the atom. But apart from the nucleus, most of an atom is actually empty space. You've got the electrons, which exist in shells around the nucleus, but most of that atom is empty space, so it's untrue to say that atoms are tiny, hard spheres. The current model of atomic structure is then outlined here. It's made up of 3 particles. You find the protons and neutrons in the nucleus, and then the electrons are in the shells. You need to know the charges and the mass of the protons, electrons, and neutrons. Okay, that's outlined here in this table. Neutrons are neutral, okay, they've got no charge. Protons are positive, think P for proton, P for positive, and then electrons are negatively charged. When we're talking about relative mass, it's the mass compared to each other. Because protons and neutrons both have a mass of 1, that means that they have the same mass as each other. You'll see for the electron, it's written 1 divided by 1835. That tells you that the electron has a mass that is 1,835 times lighter than a proton and a neutron. Protons and neutrons are already incredibly light, so to be 1,835 times lighter means electrons are so light that we don't count them when we're looking at the mass of an atom. We say the mass of the electron is negligible, so light it's not even going to count. If we look at the following worked examples, this outlines typical questions you might get on atomic structure. The first is, what is the charge in the nucleus? Okay, we know that the nucleus contains protons and neutrons. Protons have a positive charge. Neutrons have a neutral charge. But because of the protons, overall the charge in the nucleus is going to be positive. Where is the mass of the atom concentrated? If you look at the 2 particles that have mass, you've got protons, they've got mass, and neutrons, they've got mass. Protons and neutrons are both found in the nucleus. So I can say the mass of the atom is concentrated in the nucleus, okay? That's because you find the protons and your neutrons in the nucleus. If you're asked to compare the modern model with Dalton's model, you should be giving a similarity and you should be giving a difference. In the first line, I give the similarity. Atoms are tiny particles that make up all matter. Okay, that's true today, and it was true in Dalton's theory. However, Dalton said that atoms were tiny hard spheres and they couldn't be split into anything smaller, whereas now we know that they can be split into protons, neutrons, electrons, and are mostly empty space. So in a compare question, give a similarity and then also give a difference. The last worked example suggests a limitation of the current model. So this here is a rough diagram of the current model of an atom, and it doesn't actually give us a correct impression of scale. The nucleus is much, much smaller than the rest of the atom. So these shells would take up a huge amount of space relative to the nucleus. And when we draw these atomic diagrams, they don't give us an impression of this scale. You need to be able to work out how many protons, electrons, and neutrons are in each atom. To do this, you'll use your periodic table. And this is a little screenshot of the actual periodic table that you get in your exam. And you'll see that it has this key next to it. And this key tells you how to read your periodic table. It tells you that the number at the top is the relative atomic mass, so the mass of the atom. It tells you that this Be is the atomic symbol. It tells you that this small little word here is the actual name of the element. So beryllium is the name of the element. Be is its symbol. And then at the bottom, it tells you that this number 4 is the atomic or proton number of beryllium. Okay, so it tells you on your periodic table that the smaller of the two numbers is the number of protons. So if I wanted to work out the number of protons of beryllium, I go to my periodic table, I look at the number at the bottom, and I see that it has 4 protons. The protons for lithium would be 3, the protons for sodium would be 11, the protons for magnesium would be 12. You're always taking this bottom number, which is the smaller of the two numbers. If beryllium has 4 protons, then it will also have 4 electrons. The number of protons and the number of electrons is always the same in a neutral atom. So if lithium's got 3 protons, it's also got 3 electrons. Sodium's got 11 protons, it's got 11 electrons. Magnesium's got 12 protons, it's got 12 electrons. Those two numbers will always be the same. To work out the number of neutrons, then you're going to use the mass number. Okay, so remember, protons and neutrons are the two particles that have mass. So this larger of the two numbers here, the atomic mass, that is the protons and neutrons added together. If we know that you have got 4 protons, then if we do 9, which is the total mass, minus 4, we can work out how many neutrons you've got. So in other words, to work this out, you're using the small number for protons, the small number for electrons, and the big number minus the small number for neutrons. Below, I've worked this out. So for sodium, I said it's got 11 protons because the small number next to sodium is 11. It's also got 11 electrons because protons and electrons are always the same. And then to work out the number of neutrons, it's the big number 23 minus the small number 11, giving you an answer of 12. Be careful with this next question. What does the atomic number of an atom tell you? It's written here for you on the periodic table that you'll have in the exam. It says the atomic number is the same as the proton number. So your answer is going to be the number of protons. That's what the atomic number tells you. And I know the electrons are the same, but if you write down the number of electrons, you're not going to get the mark. The atomic number tells you the number of protons, and then once you know the number of protons, you can work out the number of electrons. But if you write electrons here, you're not going to get your mark. What is always different for different atoms, or what particle do you use to identify the atom? That's going to be the number of protons, okay? You always take the number of protons instead of the number of electrons. And the reason is that the number of electrons changes. We know when we do chemical reactions that elements can lose electrons, they can gain electrons. The number of electrons can change, so we never use the number of electrons to actually identify an atom. The number of protons doesn't change, so we're going to use that to identify an atom. So for example, if I said an element has 12 protons, what element is that? I look at my periodic table and I see it must be magnesium. If you're told an element has 4 protons, what element is that? You look at your periodic table and you see that it's beryllium. Why is an atom neutral? So I've written 2 answers here. One of them will get you 3 marks. One of them will only get you 2 out of those 3 marks, okay? To get full marks for this, you have to say protons are positive, okay, or they have a positive charge. Electrons are negative. I look at sodium, which I had before. It had 11 protons and it had 11 electrons. Protons are positive, so it has 11 positive charges, and electrons are negative, so it has 11 negative charges. The positive charges and the negative charges cancel out. 11 minus 11 is 0. So overall, the atom is neutral. This answer here says, so the electrons and protons cancel each other out. But the reason they cancel each other out is because you've got the same number. If you had 10 protons and 11 electrons, they're no longer cancelling each other out. You have to say same number of protons and electrons to get the full 3 marks. So this answer here will score all 3 marks, whereas the answer on the left will only score 2 because you haven't specified that you've got the same number of electrons and protons. The last question here, why are the mass of electrons ignored? And they're ignored because electrons are so light that we just say that their mass is negligible. To practice going through this information, I would suggest trying these practice questions. Section A, short 1 mark questions. Section B, slightly harder. Have a go with the section A questions. Press pause, try and answer them for yourself, and then press play when you're ready to see the answers. Okay, so I filled in the answers. I won't go through all of them, okay? Just for this table at the top, okay, the number of protons is going to be the atomic number. So the atomic number of iron is 26, number of protons is 26. The number of electrons has to be the same, so that's also going to be 26. And to work out the number of neutrons, it will be the mass number, 56, minus 26 gives me 30. So it's always the small number, the big number, minus the small number of protons, electrons, neutrons. These questions should all be straightforward. Just be careful here on number 12. The atomic number tells you the number of protons. 13, the mass number tells you the number of protons and neutrons. Protons and neutrons both have mass, so the mass number tells you the number of protons and neutrons added together. I'll just go through 14. The atomic number of oxygen, the atomic number is always a small number, so that's going to be 8. The mass number of neon, the mass number is the big number, so that's a 20. Big number is 20. Electrons does nitrogen have? You use the small number for electrons, so that's going to be 7. The protons and fluorine, you use the small number, that's going to be 9. Neutrons for boron, for neutrons it's big number minus small number, which gives you 6. And the atom with the most mass is neon, it's got the biggest mass number. What's always different? The number of protons is always different. Okay? Got a few more questions here in section B that are slightly longer. Have a go with section B. Press pause and come back when you're ready for the answer. Okay, so we'll go through section B. For number 1, why do atoms have a neutral charge? I've already written this out for you here. You're using the answer on the right. You have to specify that they have the same number of protons and electrons, which is why the charges cancel out. For question 2, 2 differences between Dalton's and the current model. Difference 1 would be that you can split atoms into simpler particles. Difference 2 would be that atoms are mostly empty space, not tiny solid spheres. Limitation of the current atomic model, it doesn't correctly represent scale. 4, the mass number is 23. How many neutrons does it have if it's got 11 protons? To explain, just show the calculation. 23 minus 11 is 12 neutrons. A lithium atom has a symbol 7,3. Explain in terms of subatomic particles when the mass is 7. So the small number 3 tells you it's got 3 protons, but if it's got a mass of 7 overall, then it must have 4 neutrons. So you would say it's got 3 protons. You would say it's got 3 protons and it's got 4 neutrons. That's why it's got a mass of 7. Remember, protons and neutrons are both have mass. A chlorine has 17, 17, 18. What is the mass number of this chlorine atom? Okay, so which particles have mass? Protons have mass, neutrons have mass, 17 protons, 18 neutrons, add them together and you get 35. The total mass will be 35. You're going to use this table to answer questions 7, 8, 9 and 10. Which of the above particles are neutral atoms? Remember, to be a neutral atom, you need the same number of electrons and protons. Particle W has 9 electrons and 9 protons, so it's going to be neutral. Y also has the same number of electrons and protons. You can see it's got 16 for both, so Y is also going to be neutral. Which is a negative ion? Remember, electrons are negative and protons are positive. So to have a negative charge overall, the particle must have more electrons than protons. So if I go down through the different rows, I will see that Z has got 18 negative electrons and only 16 positive protons, meaning Z is going to be negative overall. A positive ion must have more positive charges, so it must have more protons. If I look at the table, I see that X has 12 positive protons, only 10 negative electrons, meaning that X is going to be positive overall. To identify the particles, I'm going to look at the number of protons. So I'll go to my periodic table and I will see which element has the number 9 as the small number. And fluorine has number 9 as the small number, so W will be fluorine. Magnesium has number 12 as its small number. Sulfur has 16 as its small number, and then Z also has 16 protons, and that tells you that Y and Z are the same element. Make sure that you're looking for the small number, okay? If you just look for the number 12 on your periodic table, you're going to find it in 2 places. You're going to find it next to magnesium, and you're going to find it next to carbon, okay? but I need number of protons. Remember, the smaller of the two numbers is number of protons. So magnesium has 12 as its proton number, but you'll see that carbon has the number 12 as its mass number. Okay, when we're identifying, we need number of protons. So I'm going to be looking at magnesium because that has 12 as its proton number. In the next video, I will go through the rest of this topic, which will be isotopes and relative atomic mass.